Hello. Welcome to our next session. We have 45 minutes of an excellent panel, you could say interview, here on stage for you next. And since we have a fabulous moderator for this one, a great lady, I'm not going to take away too much. I'm just going to say what the title is, the Roadmap to Carbon Neutral Mobility, and they are going to discuss a lot about that. I have here for you Andrea Thilo, who's going to moderate, and then her fabulous guests, Dr. Thomas Becker and Alexander Horst. Enjoy. I was just about to say, viel Spaß. Here we go.
Thank you very much, Hannah. And a very warm welcome, everybody. We are very glad that you are going to join our session on key success factors for carbon neutral mobility. Let me just start with some figures to be shared. With global mobility demand growing by 70% over the next decade, the industry is to exceed its estimated carbon budget by 2.5 in 2030. The successful decarbonization of the vehicle use phase through electrification and through green energy supply will not be enough. With this session, we'll bring across the complexity of decarbonization behind the surface and what the industry is going to tackle, to resonate on that subject. And we will share insights on how creating meaningful progress and circularity that will only be possible if the current system is transformed and the ecosystem goes beyond optimizing in industry silos. So the BMW, and I will refer to you in a second, is putting circular economy and sustainable urban mobility at the center of its presence at this year's IAA Mobility. You've probably already seen it, and we all hear a lot about it in the international press. So rethink, reduce, reuse, and recycle is the credo. I'm now very glad to welcome our two speakers in this session, Dr. Thomas Becker, Vice President Sustainability Mobility at BMW Group, and to his right and your left, Alexander Holst, Managing Director Sustainability Strategy at Accenture, who will share his keynote and a few slides in the very beginning. First, thanks goes to you and to Accenture for setting up that session. So before going on, maybe Alexander, I leave the stage to you and your insights.
Thank you very much, Andrea, and a warm welcome to everyone on this afternoon. I believe it's actually time to say thank you and to be a bit proud, and also to stay ambitious. To be proud and say thank you what the OEMs, the car companies, and the entire ecosystem has done over the last 5 years. I remember 2016, I did my project for a large automotive company, sustainability strategy, discussing carbon, human rights, all these ecological societal aspects with a car company back in 2016. Different discussion. And now we are today here and talk about carbon neutrality of the entire life cycle. And the halls are full of new vehicles that you can actually buy and not just see in a pilot stage. So that's the good news. But we still need to be ambitious. And I will share you why on this aspect. Now, why do we talk about carbon neutrality mobility and not just electrification or decarbonization of the use phase? Because of that slide. You see on the very left, you see the carbon emission on the life cycle on a normal average car with 147 per passenger kilometers. If you take the electrification on the average German CO2 content of the grid, it goes down to 125, so not so much. If we then have full renewable energy for the electric drivetrain, then it goes down to 47, which is wonderful, but not enough. Not enough to meet our carbon reduction goals, 1.5 degrees or even 2 degrees for the mobility sector. For that, we do need a circular car. We need to look at the entire life cycle. And that just doesn't mean the production plant, whether in Munich, in Ingolstadt, in Stuttgart or in Wolfsburg or somewhere else. It means all the suppliers that supply the materials, the steel, the plastic, the aluminum, the batteries, the stuff that we actually use when we drive the car. Now, that is the tricky thing. And that's what we call circular cars. But what is a circular car? Obviously, it's not a car that drives around in circles, and it's made out of 100% pretty ugly recycled material. So it's something else. In our view, and we developed this view together with 40 other companies, over the last 1.5 years, under the umbrella of the World Economic Forum and the World Business Council for Sustainable Development. With 40 other companies, OEMs, OES, chemical companies, we developed an idea of what a circular car looks like. And it has 4 key components. One is the energy. We all talk about that. This is key, the renewable energy. Then we talk about the lifetime of components and materials. Then we also talk about the materials, right, in terms of whether they are reused and recycled. And there's a great initiative and from you, from BMW, having secondary first, think about, in this differently. And then, of course, the use rate, which many car companies tried already some years ago with some success and some failure, mobility as a service. But those 4 components make up what is circular cars. Now, how do we measure that, or how do we define a circular car? We define it with a taxonomy. And I'm sure you remember, or you have in mind, the taxonomy of the autonomous driving. Level 2, level 4, level 5. And this is how we tried to do this with a circular car. Get a common language of the participants of the ecosystem, of the value chain, that they, when talk about circularity and mobility, they actually know what they mean. They have a common understanding. And from level 1, maybe today, all the way to the visionary level 5, which we may never achieve, or sometime, there are differences, there are the paths. And in order to understand where we are right now, we can measure that taxonomy. And we measure it with 2 key KPIs. And the KPIs are carbon efficiency, in the sense also over the life cycle of a car, but passenger kilometers. That's an important component, the passenger per kilometer, because that's the actual service. That is the stuff that a car actually is for. And the resource efficiency, also measured by passenger per kilometer. And if you see how we perceive this going forward over the years, all the way to 0 ideally, and maybe even positive. Imagine a car that when it's driving, it's positive for the environment. Well, that's really different to the discussion of the last 40, 50 years that we are having, especially in this country. But imagine this vision. You drive and you feel good about it because you have a positive contribution to the environment and to the society anyway, because mobility is something that is important for democracy. Now, there are 4 pathways to get there, and they're very much related to the 4 components I just said. The energy decarbonization, of course, the material circularity, the lifetime optimization aspect, and then the utilization improvement. Every of those 4 pathways is somehow connected. You can go one on your own, but it doesn't lead you to level 5. Only if you go all 4, you take the level 5. And as a company, not all individual steps are in your hand. You need to work together with suppliers, with regulators, with other companies within your value chain. And this is all good, right? And this describes the vision, this describes the pathways, this describes how we measure a circular car. But there are already, of course, practical steps. And companies in this sector have done circularity, whether it's called reuse, or remanufacture, or recycle, over the last 100 years, 50 years, 80 years, right? I mean, certain components are being recycled for decades, right? So this is not new in the very micro sense. It's new, the broader view, the 4 different pathways. and the interconnectedness of those 4 pathways, that is new compared to maybe 20 years ago or in the 80s when we talked about certain aspects. And last but not least, you see here certain aspects in 3 very concrete activities that are being conducted right now under the umbrella of the World Economic Forum with the World Business Council for Sustainable Development. Thank you very much.
Thank you very much, Alexander, for this roadmap to the future. And referring to what we just heard, let's take that concept to reality. Yeah? From the BMW perspective, and you just presented a prototype of the circular car at the open space of IAA. People have been very, not only surprised, but I think very much in favor of it, of that movement. Talking about reality, where do you see BMW in this circular path now in the taxonomy, and what are the steps to the future to really achieve carbon neutrality?
So at the moment, we have an average recycled rate in the average of our products of something around 30%. So we have components made, for example, of cast aluminum, where we are at a rate of 50%. We are in the very relatively low 1-digit percentages for glass. We are at not even 10% for plastics. So it's a mixed bag.
Yeah.
And we need to move up radically because we need to bring the supply chain down. And as you just described, the paradigm of sustainability is massively expanding. I mean, until a few years ago, it meant have your house in order, meaning produce cleanly, efficiently, without wasting anything. And the other aspect was tailpipe emissions.
Yeah.
So it was about CO2 saving, about Euro 1, 2, 3, 4, 5, 6, and it is now about the drivetrain. But that's not it. I mean, if you look at the logic established by the Science Based Targets initiative, which very clearly defines what it needs to demonstrate, am I Paris compliant? The answer is not, please make electric engines. The answer is, bring down your total account. And that one includes the electricity that goes into driving, it includes the impact of raw material extraction, it includes everything. And here we need to act, and here we have done a very, I would say, deep and thorough analysis of all elements of our balance sheet. And we can't get to Paris very clearly without massively increasing recycling rates.
Yeah, but pressure is big, time is running. So what are the challenges that you face currently in order to really bring that target to reality?
Yeah.
Is it?
So very practically speaking, if you look at, for example, corrosion resistance of metals, there are factors which really put that at risk. So very tiny contaminations of copper, for example, in steel, they will risk the very capabilities that this material needs to have for a car. So a lot of the stuff that comes out of shredders today will end up in construction. Aluminum that has been a car may end up as a Coca-Cola can. But to have a quality that is really automotive grade is a challenge. And there are 2 key factors to repair that. One is better shredding, sorting technology. The other option is design for recycling. Well, design for recycling is what you can do for future cars, not for the ones which will come back for the next 15 years. So we need both approaches.
So if I take what you just say, that means like we are more or less following the road that is already started until 2025, 2030, 2035, and then we may have kind of a disruptive change in design, etc. Is that what you envision?
Well, it's for design, indeed, and this is what we show here at the exhibition. It's about simplifying architecture. It's about replacing highly complex composite materials by material fractions that can more easily be separated. It means not to have a digital device in each and every corner of the car with a wiring harness that is kilometers long and spreads into each and every part of the vehicle. It means supporting a proper dismantling and recycling from the outset. But it also means to use recycled material where we see very many innovative technologies. So we work with a variety of startups in order to develop recycled material that has what obviously counts for us, which is a premium feel, an luxury appearance. And what you see here at our stand, I think, shows that recyclability, that circular readiness does not mean austereness or ugliness, but to the contrary.
We'll look at the whole taxonomy in this 45 minutes, but let us just share some other figures. Even if electric vehicle sales continue to grow at the current rate of approximately 30%, we will have a global fleet probably percentage of 15 to 20%. How do you view these figures in total? Alexander?
No, well, I mean, it just means that this, in the next 10 years, what you said, even with this high growth rate, we will not change the world.
Yeah.
And I guess that's reality check.
Yeah.
Right? It's very similar to renewable energy. The renewable energy needs to grow rapidly if we want to translate the entire electricity demand, not energy demand, into windmills. That would mean every kilometer, every cell of a kilometer, one windmill in Germany. Yeah. Is that possible? Of course not. So the next 10 years, lots of stuff will happen.
Yeah.
But just on this recycling thing, the need for collaboration, the need for value chain collaboration is very, very critical. BMW cannot think about a material today if they don't have in mind what the recycling industry, and the recycling industry over the last 30 years, I mean, is it a high-tech industry? I don't know, right? So is it an overcapitalized industry? Well, we don't know. So, but you cannot design something without in mind what the other industry that takes care of that in 10, 15, 20 years can actually develop. So you need to view the technology path of your downstream partners. Yeah. The same of your upstream partners. But someone has to start, and someone has to motivate and coordinate, right? And that there is the big role of the OEMs, of course.
And I mean, just an example, what we are doing together with Alba from the recycling side and BASF from the plastic side is precisely looking into these options. Yeah. On the one hand, to see how can I get better recycled material coming back from the recycling industry, meaning purer materials with better capacities. On the other hand, what are the limits of mechanical recycling, meaning shredding, melting, casting new, compared to chemcycling, meaning really creating new chemicals which have all the breadth of applications that we see. But there are trade-offs. It's about, for example, the energy footprint of chemcycling. So will the entire balance sheet work out properly? It depends on the electricity scenario, as you rightly say. So there are very many variables which need to come together in order for this to become a true success.
Yeah, but if I follow your thought, the green energy path for chem recycling, for example, seems to be key, absolutely, to make that carbon neutral, isn't it?
Absolutely.
Yeah. I would like to come back to your pathways that you have been laying out. Energy decarbonization, material circularity, lifetime optimization, and utilization improvement. Please, Dr. Becker, can you make it as concrete as possible? What are the next steps you have to prioritize in order to really manage that path that you were focusing on?
Well, what we have done is, when we started from the CO2 perspective, we have created an abatement curve, an established tool where you compare how much CO2 saving do I get for the euro I spent. So, and here we already saw that just by replacing today's energy supply with green energy, we have a relatively fast lever, which will have a relatively huge impact in the energy-intense fields like aluminum and steel. And I think we will achieve significant progress with that. But it won't be enough. And this is where recycling comes into play, where we see where is the biggest potential, the biggest bang for the buck, if you like, in which material and in which component. And this is how we prioritize. But on the other hand, let's face it, as much as the job will not be done just with the electric drivetrain, it will also not be done with just meeting Paris. Just meeting Paris. I mean,
Yeah,
if we,
just meeting-
if we
just
meet
meeting
Paris, will people say, fantastic automotive
Yeah.
industry,
Yeah, yeah.
your job is done, we leave you alone?
Yeah.
No. We will have to answer the question, how much resources have you needed? How much holes have been dug into the ground for what you make? What were the conditions for the production of primary material? So I would expect, and this is part of what we are envisaging, that resource consumption as such will mean more beyond just saving CO2. And a lot of the conversations we are part of are about things like supply dependency, about the impact in terms of labor conditions, of social conditions, and the environment of raw material extraction. So therefore we think there is, let's say, a case beyond CO2 for a circular economy.
What are your visionary figures in reducing raw materials, thinking about the near future at BMW?
So at the moment, as I said, we are at roughly 30% recycling.
Yeah.
Our next step, if you like, is to reach 50.
Okay.
And the application of that will be the generation of vehicles that will start rolling out from 2025 onwards. But also here you have a change. If you design a car to meet Euro 6 emission requirements, it meets these requirements on the first day of production and at the last. The CO2 average figure is the same at the beginning and at the end. The electricity need of an electric vehicle is the same on day one and on the last day of production. For the footprint, this will change. If we will inform our customers in the future about the footprint of what they buy, the first customers will get a different figure than the last one. And this is also something that needs to be understood and communicated.
That's interesting because it relates to our panel yesterday. It was a lot about consumer centricity and information of the consumer and communication, etc. To put the consumer knowledge and the cooperation with the consumer in the center of it. Do you think that's key, Alexander? To take the consumer very serious in his decisions and her decisions, to really make them mature to take decisions in that journey?
Yes and no. I mean, the normal reaction would be yes, of course, but sustainability is complex. Do I, when 100 years ago or 150 years ago, when we all were running horses, if the consumer would have been asked, how do you want to change your mobility? They would have said, a horse that is faster and eats less. No one would have said, I need a car, right? So am I able, as an individual, to think beyond my some yes, some not? And then where a good example of system thinking, collaboration is a bit more needed, and that is not the individual consumer, is where I live right now, southwest of Berlin, right on the border. Now we have election all over there are the advertisement. One party wants to build an underground, extension, 3 kilometers of underground into Brandenburg, where I live. So suburbia, yeah? I mean, the most expensive transport mode, underground, in suburbia. Single houses, everyone has a car, a larger car,
Takes
of course.
10 years to build.
I mean, takes 30 years, right?
30
I mean,
years.
in Berlin, Brandenburg, usually 30 years. So, I mean, that's one party. The other party goes for nostalgia Straßenbahn, right? Which, of course, is a lot cheaper and probably better, but I don't know. No one discusses a semi-automated kind of mini transport system, like 20 minutes, 10-minute kind of on-demand buses, mini buses that go into the different suburban routes, right? That would be the fastest, right? It would be the cheapest on CapEx, no invest, only the buses, right? And also the OpEx probably would be, I don't know. But that would be the best, using digitization, using on-demand, and really for the resource use being best. This is on those 4 pathways, the utilization, right? The mobility as a service. And
yeah.
it's not on the politicians. It's
Yeah,
not
but taking that as a question, talking about the mobile ecosystem, we have a lot of new players on the ground, tech companies disrupting, coming into. You were talking so much also about collaboration. So what are the key challenges in talking about data use, etc.? What are the key challenges in this kind of collaborative mode we really need to achieve carbon neutrality?
So talking again about our piece of hardware, this is why we initiated what is called Catena-X.
Catena-X.
That means a standardized data transmission through all the tiers of the supply chain in order to have aggregate CO2 numbers, for example.
Yeah.
Ones which are credible and where our accounting systems can aggregate in a way that at the end of the year, when we publish our integrated report, there is a number in there that's right for the group, which can be broken down to the product. So this is one example why digitalization also of the supply chain has a huge impact on sustainability and managing sustainability and measuring sustainability. But if we talk about collaboration on the road, what we show here in Munich are two ideas which cannot be sold at the moment because they are not legally feasible under the current conditions. They are called AMBI, which is the abbreviation of adaptive mobility. They are something between a bicycle and a motorcycle. So we make motorcycles longer than we make cars. So apart from an electric motorcycle or electric scooter, the idea of this AMBI is relatively simple. It is one device which can run at 60 kilometers an hour for distances which are too far to travel by bike. So I will not drive to my office 30 kilometers every day on a bike, not even on an e-bike.
Yeah.
But I may use this one. So it takes me relatively fast into the city. But then I would say, okay, I would rather use a bikeway, or I would like to ride along the river of the Isar River's banks on a bike path. And as soon as I leave the road, this thing knows I'm leaving the road.
And it
will reduce the maximum speed to 25. The number plate that I need for the road can go away. And I use it like a bicycle. So it is an option
sticking
to
with that
change
thought,
things.
we have data already to organize individualization for very carbon neutral goals. What kind of regulation, besides the example you say, are in the way of achieving what we are talking about? Alexandra, maybe you have another thought to that. So what kind of regulation, maybe also on EU level, has to change that we can really cooperate in bringing to life what we are talking about?
Well, regulation and cooperation, I wouldn't know that in the sense of, I mean, the European Union, what are they trying to do? One is demand signals, right? Creating demand signals. We've spoken before it, so telling, giving, like, you need to have X% of green steel. That's one demand signal, giving the participants in the industry some kind of security that there will be demand. Therefore, I am investing. The other one is, of course, the carbon price. So, okay, carbon price, and then with the leakage, so the European Union carbon border tax discussion, you know, one way, the other way is you can also do it without border tax, different ways to organize it. So you give the carbon a price. The third one is you give certain individual technologies a subsidy, right? Because you believe that's the right technology. And the fourth one is you do the big sustainable finance initiative where you basically try to create cheaper money for something that you call green. Those are 4 instruments. Now, there's a general spirit amongst those 4 instruments. That means the government knows what's right, right? And the more you have micro organization on a micro level, usually the government is not right. Right? On the big pieces, the big direction, there's a budget on carbon. You know, now the price will be on the market. You know, not, I'm always a bit worried about 30 euros, 50 euros, 100 euros. Like, well, that's not the point. The point is the budget in ton, in million ton, in gigaton. And then you have the economies working it out and the price will follow. That's the logic. I understand sector-specific targets for sector because you don't want to put all pressure on one sector, which means the energy, and then we're running out of coal plants in 2 years and getting the nuclear power plant from France electricity just like this, because that would be most efficient and carbon-free. And somehow we don't want that. Okay, but this is, in terms of regulation, those 4 aspects is what the European Union is playing. And I guess this will continue on that road. But the market, the technologies, now with wind, with solar costs, with electric batteries, they are coming big time.
Yeah.
And they're making a lot of regulation not needed on a very specific thing. Because, I mean, lots of political discussion originated 20 years ago.
That's, yeah.
You know, and now, because the process in a society just takes time, now it's ready to decide yes or no, but the decision is not needed anymore because the new stuff is out there tomorrow. But politicians then tend to take still the decision because it's a 20-year-old discussion. You know, you have this classical sort of breakaway, Bremsspur, you would say, which is normal for democratic societies. That's a process, right? And I think technology will solve a lot of problems.
Do you want to join in, or you're just in tune
I
with
would
his
like
argument?
to illustrate
Please.
that. I mean, clearly, a predictable rising carbon price is, I think, one of the most important factors that governments can do in order to change the ratio between energy sources and to change the ratio between primary and secondary material.
Yep.
Because at the moment it's about price and it's about scarcity of volume that we are struggling with. So here I think this is the best way to provide a push for the market. But if I simplify things, if you talk about the footprint of a car, you have 4 material categories: steel, aluminum, plastic, and the stuff that goes into batteries. And for all 4 of them, you have option A, change the energy input for primary materials, and second, raise the quota of secondary. So it's 8 boxes. And if now a government says, well, in Germany, we want a quota for green steel, you take one of the 8 boxes and say, this is what you have to do.
Yes.
The French government may say, yes, but you need to have a minimum quota of nuclear-powered aluminum of X. Then comes somebody who says, and you need recycled plastic. So you end up with a baking recipe for a car. And you have obviously built-in intra-industry competition for lobbying. Yeah? So if we end up in struggling for who will get their share of the automotive cake at government level, I think that won't take us anywhere.
And let me sort of just...
Please, go ahead.
There's a client of mine who's in Germany, automotive company, and there's a car supplier that is in France. And we are discussing, you know, circularity, circular products, design, and exactly that question comes. The automotive company in Germany, of course, wants renewable energy, carbon-free. Carbon-free energy equals, or electricity equals, renewable electricity. The French supplier says, wait a minute, I mean, it's all carbon neutral, right? But, you know, I mean, in France, there are some nuclear power plants.
Sure.
So then you have that discussion on company level, and if the government then make quotas, as you said, it becomes pretty tricky for you guys.
And maybe a quick question, just a short answer, to the steel subject, open versus closed loop. You already talked a bit about it. What is your attitude?
Well, I think at the moment we have things which can be done relatively fast. So having electric arch furnaces already brings you down significantly. It also allows for relatively high scrap steel usage. So obviously the ideal scenario would be DRI, as they call it, with hydrogen. But that's quite a few years down the line. And what we are doing at BMW is set targets every year and monitor every year. So politicians have the tendency to talk about the perfect status at the end of the line in 2030 or 40. But let's face it, as far as I know, the realistic volume of green hydrogen is already overbooked by a factor of 2, 3, 4. I don't know. So let's rather see that we get the right mechanisms in place, that we support new technology development, and that we ramp up the availability of things like green hydrogen as fast as we can. But let's not regulate today's purchasing by 10 years expectations.
You just said monitoring. Let's come back to the CO2 emissions. How easy, it's an open question maybe to both of you, how easy is it to get reliable CO2 emission figures along the whole supply chain and the whole production of a car? So
very frankly, we start where it's easiest, where we have direct suppliers who have the direct impact. So if we talk to an aluminum supplier who directly purchases the energy, I think they can give clear and reliable evidence what they have done. So these are relatively big impact decisions which we take now, or have already taken, with quite many of our first-tier partners. The reason why we do Catena is to get more and more of the more complex supply chains properly monitored, because you can't do that by hand. You can't do that with an Excel sheet. And the reality is that today, if somebody calculates the life cycle balance sheet of a car, they use standard data that comes from something that is called the Gabi data file. This means that in this file you have a number for aluminum from Europe, steel from China, with average footprints. So you break down the car into its components, into kilograms, and then you allocate the CO2 footprint. So if you have done that, you get a car that is based on regional averages. So if we now have first-hand data, we replace the average data by first-hand data. And this needs obviously to be safe. And our certified accountant, who certifies our business figures, certifies our CO2 figures. So these guys want to see this properly being checked, properly monitored, and all of this needs to come together in order to have a real reliable system. This is why we would strongly support, as a reasonable government activity, to support the standardization of data quality of everything that is related to the accounting of CO2, of primary material use, and all the aspects that are related to it.
Please, Alexander.
Yeah, I think the automotive industry on this particular point is leading in that sense. And you're leading because you have a regulated impulse, right? The CO2 matters for you as a cost point. And you really have an interest that your supplier actually gives you correct data. And when you're European-based, you might even have a chance that your real data is better than the average data that comes out of the database, right? Similar when you have and when your suppliers are active in sourcing renewable energy, then you really want to make sure you get the real data point from your supplier, not just the German or European average of that item. But I think here the automotive industry with Catena-X is really leading. And other industries might learn from that.
I have another question.
And it's very tricky. It's very hard. Not many suppliers know the CO2 footprint of their product on product level. You know, the big corporate, they can somehow then, with all the real CO2, not just, again, the average data, right? The supplier gives you the average data. This is my product, has 25 kilogram per product unit, but then it has maybe a plus minus 40% kind of, can be right, can be wrong.
Yeah. We are entering the last 7 minutes of this discussion. What I think is very interesting, we are talking about consequences and next steps that are incredible investments in the industry and from the industry. I want to know from both of you how, coming back to the taxonomy question, how to bring it from a cost driver to a driver of value. What are the value propositions? What are business models, etc.? So how to further develop that future? Yeah, maybe Alexander, you want to start?
Yeah, I guess if you talk about value, you can wonder like risk, reducing risk. So you can think about change materials that are more riskier, also in the supply chain, have higher risk, and therefore you decrease your risk, and therefore you decrease your cost of capital. That's one value driver. Climate risk is one aspect. The more carbon intensive you are, the more climate risk you have, and you get a discount from your investors, one aspect. The other aspect is, of course, you can add revenues, so whether new customer segments so you, that are interested, or you get the license, you keep the license to operate, purpose-built vehicles in certain aspects, you actually right to sell and the right to innovate, because people or other companies like to partner with you. That's very important, that you have a front-runner image, so you have the license to innovate in a world where smart brains are scarce, right? If no one likes you, you know, tricky. Either you have so much cash that you don't care that you're being unliked, or you know, you are a partner in the ecosystem. Then, of course, sometimes increasing sustainability is also about increasing efficiency, and very often, and therefore you can reduce cost. And then you, of course, have the image factor, but that I would always put last. The other three aspects, cost, risk, and revenue, I would increase.
Dr. Becker, your thoughts on that?
I mean, clearly electrification changes the entire economics of vehicle recycling. So it's a different value proposition, and it will change the business. But the regulator will too. So if you look at the draft European battery regulation, it foresees very ambitious secondary material rates for new batteries. So there is not only the need to make things recyclable, but to actually purchase stuff that is recycled.
Yes.
So that's quite a game changer.
Game changer.
And as you indicated, today's entire recycling business is the one that was shaped by the regulation for old vehicles in the year 2000. So if we see the revision of that in 2 years' time, things will change. And we will see, obviously, big struggle between the various players, including the question, do we want still scrap to be exported? Will we have, also in 20 years from now, a situation where roughly a quarter to a third of the cars sold in Europe end up in Northern Africa or Ukraine or elsewhere? Many question marks where big debate is ahead of us, I'm pretty sure.
Yeah, yeah. Is there any question? I have a last question that I want to pose to you at the very end. But is there anything that a stone we didn't turn yet that you think that is key to talk about? I mean, Accenture is key in digitalization and tech. So did we talk enough about tech, about the role of tech in the whole systematic change? Yes.
Well, I think we touched one aspect. I have got 3 examples. The recycling. You can use artificial intelligence to increase the recycling, to improve the recycling process, actually big time. Or you use the digital twin, which is in product design very much used. And if you factor in CO2 or other resource aspects, and even human rights aspect into your digital twin, within the product design for the production, but also for the use phase, you can, actually decrease a lot of carbon. We did a study for the German IT Association where we calculated the different technologies, and we came up with 80 to 120 million ton of CO2 reduction by 2030. That's around 30 to 40% of the entire CO2 reduction needed by Germany just by digitization in a positive sense, since having a net positive effect. And digital twin was the major contribution. And the third example is, and you're working on this already, is the product passport. So you have the product passport that contains the entire data from the South African mine to the shop floor, and when you go to the recycling, the recycler knows, okay, that's the product, and I should use this recycling process for that type of car. And that's also very important technology to support resource efficiency. So those are 3 examples.
Okay, last question. We look into the crystal ball, 2025. What will be the discussion at that panel of IAA that you are sure you have to lead or to dive into? And what are you sure we will have left behind by 2025? Maybe you start, and finally, Alexander. Yeah, please.
So I'm pretty sure we will not anymore talk about just about drivetrains. We will speak really about footprints, and we will speak about resources, and we will speak about a completely different business model when it comes to the recycling industry, I'm pretty sure. And we will look at today's situation, maybe smiling. Just one example. There is today, as far as I know, no fully recycled aluminum wheel, meaning an aluminum wheel which is only made of recycled aluminum. There are millions and millions and millions out there. So, can that stay the same?
Okay, 2025, Alexander.
Yes, my hope is that we talk about, in 5 years' time, about the fourth of the four pathway. Again, the first is all about the decarbonization of the energy. We've done it. We've built a lot of new windmills, and we get the wind from the North Sea. Blah blah blah. So that's all done in the making. On the material side, you've been successful on recycling, secondary first. You got your new sources. You invested in. You went maybe downstream. You invested into some recycling companies. So you're cool on that too. But then we talk about the business model, the utilization again, the concept in cities, even in Europe, not just in the new cities built in Asia, even in old, wonderful, beautiful cities, purpose-built vehicle, kind of models, the competition to the public transport, and really to reduce the numbers of cars. The mobility as a service is right now a little bit dead, because it was like a discussion, it didn't really fly. And maybe in 5 years' time, that's my wish, we speak about it again.
But that brings me to, time is up, very, very short answer, Dr. Becker. Do you think BMW will be still selling more than 2.5 million cars per year? Is that the business model of the future? Yes or no? Yes,
we will.
Okay, thank you very much for your bright future. Thank you to both of you, and thank you very much to Accenture to make that happen. Thank you. Thank you for your attention.
Great session. Thank you so much. Fantastic. I do have to move you off stage and do the small talk, please, behind the stage, because we have to set up for our next session. Sorry. Behind the stage or on the corner. They won't get lost here. No worries. They still have time for all the other questions. Bear with us if you can. We are coming to our last panel in just a few minutes. Exciting topics and interesting speakers. And it's about mega cities, smart cities, anything connected to those topics. And I hope you will stay for this one. Have a great time in between.